Hello guys, welcome to a new video to the next week. Today we'll be talking about UPSs, their types and such. We'll be talking about diesel generators and we'll be talking about two types of transformators. Before we spend much more time, let's get into it. And UPS is an essential power protection device designed to provide battery backup and filter electricity for critical electronic loads. While all UPS systems provide emergency power during an outage, their internal designs or topologies dictate how they respond to different power quality issues. UPS topologies. The classification of UPS is typically based on the number of power quality problems it can solve. Offline or standby 3 series. This is the most basic and cost-effective design. Under normal condition, utility power passes directly through the unit to the load. How it works. The system waits for a power failure or a significant voltage drop. When a problem is detected, an electronic transfer switch moves the load to an internal battery-fed inverter. So it basically uh, when you notice a power outage or like the power, sorry, not power, the voltage is changing really rapidly. It goes really high or goes really low. The system recognizes that fault and it shuts down. Well, not shuts down. It opens the fault case literally like this. It opens and the UPS is now feeding the entire system. Like, imagine it like this. You have it this way, this opened. Now, I cannot come from the source anymore. So what the UPS does is I put a battery here, then I feed the whatever I have on the end of the line. You can use these in houses and such places or anywhere you want, basically. We'll come to that. Let me continue reading. Transfer time. There's a brief break in power, typically under 10 milliseconds during the switch. You would notice this flickering lights or something going power on and off real quick. This is because obviously it doesn't have the high quality materials like the other types I will be talking about in this presentation next. It basically means that you would notice this if something is offline by if the light flickers like this. You would notice it. Best for home computers. Best for home computer. Sorry, home computers, modems, routers, and basic security systems. So you don't run out of uh, continuity. Oh, you wouldn't say that. So basically, that you can keep the system continuous. You can keep the system in a continuous moment. And anything else that you need to be wary of this is basically all. These are all of the informations you need about an offline standby UPS topology. Line interactive 5 series. This topology is similar to a standby UPS, but has automatic voltage regulation. What works? It uses a variable tap transformer to boost or reduce incoming voltage without switching to battery power. This preserves battery life in areas with frequent brownouts, low voltage, or swells, high voltage. So it basically means that there's no power outage, but there's a high or a low voltage problem. It basically regulates that voltage so you can use it in your home again. And this prevents you from using the UPS as an actual backup source, backup power generator. Well, not a power generator. Backup power source is the correct term because it's not a generator. It's a battery source. It basically means that you can still use the main AC source even if the voltage is, let's say, it has harmonics in it. Well, up to a certain point, of course. It regulates low and high voltage. Transfer time, like a standby model, it has a brief transfer time, typically 2 to 5 milliseconds when switching to full battery backup. Best for small business servers, network equipment, industrial applications where voltage stability is inconsistent. in industrial uh, settings, in these areas, there is a lot of factories, obviously. And even if there's only one factory is using so much power, so much reactive power that you typically make the voltage high or low really easily. And with this, you can have problems with, let's say, a server you're running or a machine that you're supposed to run, a machine that is supposed to run all the time. These cannot have those voltage highs or lows. Those peaks or those lows will make them have a failure, make them have a shutdown, or generally maybe break them if it's a really high voltage. It might burn them and such. If it's regulated, none of this will happen. It's basically the one that is more used generally because it's generally speaking, it's cheaper than the last one we're going to talk about, but more expensive than the first one. But small businesses basically use them. Online double conversion 9 series. Sorry. This is the highest level of protection available. It provides a firewall between utility power and your sensitive equipment. How it works. Incoming AC power is converted to DC, rectification, and then immediately converted back to clean AC inversion because the inverter is always feeding the load, the battery is already in line. So it basically means that I get the ACs, and regardless of its irregularities in the voltage, I am just going to turn this into DC, then to AC that I would be using. And it will be clean because I'm doing 2 transitions back to the power I need. So this way, it can actually feed the network and be, let's say, more efficient and make the harmonics disappear, basically. So as the time, there's no break in power during a utility failure because the load is never directly connected to the raw utility line because there's always 2 changes in between. You go to AC, DC, AC, and in between that you have the battery always in line. So the light doesn't flicker like this. The power went out, you can still see me, and it's right there. That's for mission critical data centers, medical equipment, and high-end laboratory electronics. All of these are obviously extremely important if you run a lab. The living organisms inside can die. You might get some air in there in a vacuum that you don't want. Medical equipment is, let's say you're doing a surgery from far away. I assume you've seen all of those stuff that you can do. You can do surgery away from that place. Sorry, I looked at that clock. Uh, if the power goes out and you miss by 1 millimeter, you might just cut someone's a neuron. You might just cut a nerve, and what else? That person is gone now. It's extremely important for critical situations and will always be used for that. Otherwise, you will be opening yourself up to a really big lawsuit. Sorry. I have to pause there for a second. Battery technology in comparison. Modern UPS systems are transitioning from traditional lead acid to more efficient chemical compositions such as lithium ion or some other ion components. They're extremely, so much better than lead acid. But the good part about lead acid is it's really cheap. And hey, who wants more money? I do. You do. So does the big companies. That's the whole idea why they would still keep using them. To choose the right UPS, all of these 3 steps. Sizing. Calculate the total power draw of your equipment in watts or volt amperes to ensure the UPS capacity exceeds this total because it needs to exceeds so it can power itself. And obviously, if it's at that limit, you need a little bit of more higher power. You're just not going to get it. then the system is going to fail again. Or you're going to draw over voltage, and that's still also bad for the UPS. Runtime. Determine how long you need the equipment to stay on. For IT systems, this is often just long enough to perform a graceful shutdown or for a backup generator to start. A graceful shutdown is basically how you properly shut down a system, or a backup generator. In this case, we are always talking about data centers. In the case of a data center, for a backup generator to start, you need for it to run for a long while because the generator needs to start running so the system doesn't fail. Power quality. If you only need protection from blackouts, a standby unit is sufficient. If you experience frequent flickering lights or voltage drops, a line interactive or online unit is necessary to protect sensitive components from wear and tear. You can just basically use a simple UPS and you'll be fine. This is basically all about a UPS. If you have more questions, you can always tell me later. What is a diesel generator? A generator is essentially two main pieces of equipment joined together. A prime mover, usually a four-stroke reciprocating internal combustion engine, an alternator, a cylinder component that converts the mechanical energy from the engine into electrical energy. How it works, energy conversion. Chemical to mechanical, as you all know, you inject fuel into the pistons. Pistons make them push down, and if I push it down enough, it's gonna light up and it's gonna push the piston back. All of that good stuff. If you're a car enthusiast, I assume you know how this works. Or if you're watching these videos, I assume you know how an engine works. Mechanical to electrical. This rotary motion spins a rotor inside the alternator. Induction. The spinning rotor induces a voltage in the stator. The stationary outer part, the difference in voltage potential allows electrical current to flow. Basically, you're using so many induction components that let's say, the part that is not moving outside and the inside part that is actually moving, like this, and this is the stator, and this is the rotor that is moving inside. You put basically bobbins on those, and those bobbins spin, magnetic field. You induce electrical voltage on the stator, and you can use that as a power source. Key components mentioned. Cooling system. The front section uses air blown across a heat exchanger to keep the engine cool. This is actually really important. Why this key component is mentioned? Because the cooling system uses that air that you're using, the rotary movement, you're using the same air to cool down the engine. You would put, let's say it's moving around here, this is the stator, you put a fan here, the fan spins this way, and you use that spin to cool down the system. Engine type. It specifically uses a four-stroke engine rather than a two-stroke, as two-stroke engines are usually reserved for much smaller or much larger specialized applications. Bigger generates more power. It is as simple as that. Typical applications. While often called emergency generators, they are used for much more. Marine use. On super yachts or small commercial ships, these are often the primary source of power when away from the shore. Obviously, you need electricity from somewhere, and you just use a diesel engine because it's the simplest way you can generate electricity. Remote locations, in places like jungle, mining camps, or construction sites where building hundreds of miles of transmission lines isn't practical, these generators provide a quick and easy power solution. I mean, I just don't want to spend money on transmission lines. So, hey, look at that. We have a generator. Let's just use it. Problem. Sorry, guys. Like, there's something wrong with my throat, man. It hurts. And it hurts. But I'm still doing all of these videos for you. So, drop a like. Hey, you know what? I can be a YouTuber sellout. Why not? That would make me so much more money. Let's continue. Now, oh yeah, I forgot. I paused the video, so it went back to the start. Now, let's get to the fun part, in my opinion. Transformers. Power transformers are generally categorized into two main types based on their cooling and insulation methods: dry type and oil type. Choosing between them involves balancing factors such as safety, maintenance, and environment. Core difference: cooling medium. Dry type uses natural or forced air to cool internal core and windings. Oil type uses mineral oil as the primary medium for both cooling and insulations. Safety and insulations. Dry type, highly safe and fire resistant because they do not contain flammable liquids. It's air. They are the standard choice for indoor installations, hospitals, shopping malls, and residential buildings. Oil type contains mineral oil, which is flammable. Internal insulation failures can cause the oil to vaporize, leading to fire or explosions. Consequently, these are usually restricted to outdoor or remote locations. Here's the deal. An oil type transformer is really simple, and it is more efficient, and it is better. Also, it's more expensive. Sorry, it's not more expensive. Also, it's less expensive, so it's cheap. It's cheaper. But the deal is, it explodes. And what happens when you put it next to children, people? Hey, you know what? People feel like hitting stuff all the time, so they're gonna hit a transformer. And hey, let's say for the sake of it, it's in an easily accessible place, because if you're putting an explosive transformer inside a really critical point, I assume you don't really care whether it's inside a safe point or not. And what are the chances that it's gonna explode? But air type, the dry type runner, yes, it gets rid of that because it only has air inside, and even if it breaks down, the the most that's gonna happen is the windings are gonna burn, but not in the sense of burning, but they're just gonna melt, and the transform is just gonna go off in a circuit breaker. But in the other one, there's a chance of explosion, and which, if I remember correctly, like 80% of almost all of the transformer failures are basically caused by winding failures, and inside an oil type this can cause explosions, obviously. Maintenance requirements: dry type virtually maintenance free. There are no liquids to check or leak. You just check if the values are correct, and if the transformer is hot or not, then that's it. Requires regular maintenance. This includes sampling the oil to check for contamination, monitoring the breather, silica gel to ensure moisture isn't entering the tank. You do not want water inside. You do not want air inside. You do not want air bubbles inside. Because all of these irregularities can cause explosions. All of these can cause uh, all of these can cause fires. All of these can cause big problems. And do we want that? No, not really. Why would I want to waste my money? But here's the catch with that. That regular maintenance is basically to check the oil and to see if oil has vaporized inside of it. Because other parts are usually fine, but oil might vaporize, and that is usually the bigger concern when it comes to oil type transformers. Noise levels. Oil type, generally quieter. The oil and the seal tank acts as a sound dampener, and it makes it really, really quiet. For the humming noise, Magno, generated by the vibrating core and laminations. Dry type, laminations, sorry. Dry type, typically noisier because the core and the windings are exposed to air, allowing the humming sound to travel more freely. You're basically making the air ionized, kind of, in a way, and you're vibrating the air. Not really ionized per se, because if it was ionized, you would be getting electrocuted. It's vibrating in a way because you're moving so much electricity, and if it's vibrating too much, you're gonna make so much noise because it's vibrations. Obviously, those are Sound is basically just vibrations, if you didn't know. And if you do so much vibrations, you're gonna get so much noise. Performance and efficiency. All type transformers are generally more efficient and have better overload capabilities. Dry type units are more prone to overheating during overloads and often have higher electrical losses. But the upside is they are really safe. Operating voltage. Oil type transformers can handle much higher voltage ratings than dry type versions, which have more limited applications. Obviously, we use oil, and we use that oil because we thought it was gonna make it so that there's no voltage problems, that they are not going to have the higher voltage jumps across this stuff. And when you use like a, let's say a circuit breaker, it's not going to cause a problem in the transformer and such and whatnot. This is why we use oil. And air type, dry type, sorry, is basically, it's cheap. Sorry, it's not cheap. It's expensive, but it's safe. It's really safe. We don't want people to die. This is it. For the same wiring, a dry type transformer is typically more expensive to manufacture than an oil type. And you can see, I put a real small comparison here. You can see what and how they behave. And I will put the videos down. I recommend them to you. I implore you to go watch them because you can actually see physically with the, especially with the UPS, how UPS actually behave. The three of them how they behave. You can see them more clearly. And that's all I'm gonna say for today. Thank you for watching. As always, stay tuned for next time. Goodbye.